Welcome back to Yijin Hardware. In CNC machining, chips are the material removed from the raw workpiece, and they come in various forms. Although chips are considered waste in machining, their impact on the cutting process should not be overlooked. Today, we'll discuss the 4 basic types of chips in metal cutting and how they affect the cutting process. 01. Continuous chips. Continuous chips, also known as ribbon-like chips, typically occur when machining ductile metals with small cutting thickness, high cutting speed, and a large rake angle on the tool. The cutting process is smooth, with minimal fluctuation in cutting force, resulting in a fine surface finish. The inner surface of these chips is smooth, while the outer surface is rough. Non-uniform chips. Unlike ribbon-like chips, non-uniform chips have a serrated outer surface and sometimes cracks on the inner surface. These chips are usually produced at low cutting speeds with large cutting thickness and small rake angles. Continuous chips with built-up edge, BUE. During high-temperature, high-speed cutting of ductile materials, significant friction occurs between the tool and the workpiece, causing chips to adhere to the tool edge and accumulate in layers, forming a built-up edge. 4. Discontinuous chips. These chips are typical of brittle materials. They are irregular in shape, and the machined surface is rough. In the cutting process, deformation before fracture is minimal, and the chip formation mechanism differs from that of ductile materials. Brittle fracture mainly occurs because the material's stress exceeds its tensile strength. When machining brittle, hard materials such as high silicon cast iron or white iron, especially with a large cutting thickness, discontinuous chips are common. Due to the unstable cutting process, tools and machines are prone to damage, and the surface finish is poor. Therefore, discontinuous chips should be avoided in production by reducing the cutting thickness to create needle-like or flaky chips and appropriately increasing the cutting speed to enhance the material's ductility. Different workpiece materials, tool geometry, and cutting parameters lead to various chip shapes, each influencing the metal cutting process differently. 1. When machining ductile materials at high speeds, if chips are not handled properly, long, tangled ribbon-like chips can damage tools and fixtures, pose a safety hazard to operators, and, in severe cases, cause machine downtime, disrupting production. 2. In rough turning of common metals, C-shaped chips are expected, which do not tangle around the workpiece and are easy to remove. However, contact between the workpiece or tool can cause additional deformation and breakage, leading to tool damage and vibrations. Therefore, spiral chips are the preferred chip shape in finishing operations. 3. In heavy-duty turning, low cutting speeds with large cutting depths and feed rates are typically used. The goal is to produce spiral chips that break off naturally. When cutting brittle materials, chips are fragmented and tend to fly around, posing a safety risk. To mitigate this, the tool geometry can be adjusted to produce continuous, curled chips. 5. For automated machines, effective chip breaking measures should be implemented to avoid ribbon-like or other long chips, ensuring smooth cutting operations. Subscribe to our channel to easily learn CNC knowledge and make progress every day.